For the third question, here it says the variables x and y are related by this equation, and using this equation, it can form two straight lines using the axis of these, right? So for the first graph, it's x and 1 over y. The second graph is 1 over x and 1 over xy. And when we are drawing the graphs, these would be the coordinates on that graph. Okay, so here there's a lot of things here and there, so let me help you all understand them by using diagrams, right? So the first one, variable x and y are related by this equation, so means that if we use the x-axis and the y-axis with small x and small y, right? So this will be a curve. So this is actually a non-linear equation or a non-linear graph. But how can it change to a straight line? It is by adjusting the axis of the graph. So now, instead of small x and small y, they change the axis. So the axis here would be, x-axis will still be small x, but the y-axis here has changed to 1 over y. And by using these axes, it can draw a straight line. Okay, so this one is a linear graph. Same goes to this one as well. If we adjust the graph, right, we adjust the axis from small x to become 1 over x and small y to become 1 over xy, we can also draw a straight line, and this is also a linear graph. Alright, and these values are the coordinates inside their graphs respectively. Right? So with this information, we need to express A in terms of B. So A in terms of B means that for an equation, A would be the only thing on the left side, whereas the other things would be on the right side, and one of the things would be B. So A and B are actually inside the original equation, the non-linear equation. Alright, so how are we going to solve this question? So, since they have given us the information of these linear graphs, but we don't have the linear equations yet, right? We don't have the equation of these two straight lines. So what we are going to do is, let us adjust our non-linear equation here, and we adjust it into the axis of these two graphs, right? The x, the 1 over y, 1 over x, and 1 over xy, and we see, can we find out the value of A and B or not once we change them to the linear format. Okay, so to find out the equation of a straight line, we will always use y equals to mx plus c, right? But this time, we are going to use big Y and big X. Okay, we are not using back the equation that we use all the time, which is y equals to mx plus c, right? Because now, the axis is a little bit different, right? It's not small x and small y anymore. So now it's 1 over x and 1 over xy. X and 1 over y. Very different already. So we are going to use big Y and big X, right? So for example, for the big Y here, previously it was Y, right? But now it's not that straightforward. So you can see here, the Y-axis for the first graph is 1 over Y. The Y-axis of the second graph is 1 over XY. And I can give some other examples also. For example, log base 10Y. Okay, so if we use all of these as axes, you can see there is some other things inside of it, right? So we cannot use small y anymore. We need to change it to the big Y, okay? Because it can have other things inside of it. Alright, so for the big Y here, it would be the y-axis of the linear graphs. M would be the gradient of the lines. X, the big X here would be the x-axis of these two graphs, and C would be the y-intercept. Okay, so everything remains the same, it's just that we change the x and the y to become big X and big Y. So now, how are we going to transform this nonlinear equation to fit the axis of these two linear equations? Right? So what we can do is we can match it according to the y equals to mx plus c, and we identify what is the y and the x here, the big Y and the big X here. So for example, for the first graph here, big Y would be 1 over Y. Big X would be small x. Okay, so when we adjust the nonlinear equation here, we need to make sure the left side is 1 over Y, and the right side of it will have x. Okay, so to change, what I will do is always compare the left side. Right? I can compare whether there is something missing or something that we need to add. Right? So for this one, if you see, the x on the numerator disappears. So what we are going to do is let us divide the entire equation here with x. Right? So this x will disappear. So if we divide, this x will disappear. One of the two x here will disappear also. So let me cross off the 2. And here for the bx, the x will also disappear. So it will have 1 over y equals to ax only and plus b. Right, so if you compare these two things, actually this equation has already fit the criteria, right? Because the left side is 1 over y only, and the right side here we have x. Okay, so now you can clearly see that a here is the gradient and b here is the y-intercept. Right, so once we have adjusted the equation already, let us substitute the coordinates inside this equation. Right, so for the 1 over y here, it would be negative 2k. Right, so for this one, it's not 1 over negative 2k. It's not this one. Right, it's not substituting the y only. We are substituting the entire thing. Okay, because now it's 1 over y equals to negative 2k. It's not y equals to negative 2k. Right, so we're not using this one. Okay, so 1 over y will be negative 2k, and the x value here would be 0. So if we simplify this equation, you will notice that this a disappears. So we have only left with b equals to negative 2k. Right, so now we have found out the value of b already. So let's see for the second graph here, the second linear graph here, can we find out the value of a? Right, so again, from the nonlinear equation here, we need to adjust it to the linear equation according to the axis here. Right, so for the big Y here is 1 over xy. Big X here would be 1 over x. Okay, and same as the first linear graph here, we are going to compare the things on the left side and to see what we need to add or what we need to remove. Right, so let us focus on the things that we need to add first. So if you see the denominator, it is from y and we need to change it to xy. So means in the denominator we need to add an x, which means we need to multiply the entire equation here with 1 over x. Right, so the left side here will be x over xy, and here on the right side is like we are using these values and we divide an x. Right, so here there is 2x, so I can just cross off one of the x here. Right, so here will be ax only, and for the bx here we can just cross off the x. So here will be plus b. Okay, so now the denominator is the same. How about the numerator? Right, so from x we need to change to 1. So means we need to remove this x, or meaning we need to multiply 1 over x again. Right, because x here, if we multiply this thing, it's like we remove the x. Right, x cross off with x, so numerator would be just 1. Alright, and the denominator remains the same, but the things on the right side here, we need to divide an x again. So this x will be crossed off, so here will be left with a, and for the b here, I need to divide with x, so here will be b and 1 over x. Okay, so now left side is the same. How about the right side? Okay, the right side here, the 1 over x needs to multiply with something here, right? And if we look at here, this 1 over x, which we already have, is attached with b. Okay, so for the b, multiply 1 over x here, let us move to the front of the right side. Okay, so we're gonna move it here, and a move to the back. So we can compare the values already. So you can see that for b is actually the gradient, a is actually the y-intercept. Alright, so now we have satisfied the axis of the linear graph here, so let us substitute the coordinates inside the equation here. Alright, so again, 1 over xy here, it is equal to k minus 4, right? So the entire thing here, we need to change it to k minus 4. Alright, and for the 1 over x here, we need to change it to 0. Alright, so if you simplify, this time b disappears. So meaning there's only a, and a is equals to k minus 4. Right, so now we have the values of a and b already. So how do we change it to become a in terms of b? Right, so means this value of k, we need to change it to b. Right, value of k, we need to change it to b. So for the first equation here, let us rearrange the rearrange the equation a bit. So left side would be just k, the other things would be on the right side. Alright, so if you do that, it will be something like this. So basically this negative 2, I move to the other side. So it's negative b over 2, and I switch their places. So I can change the value of k here to be b. Alright, so k, using this equation, it will become negative b over 2. And with that, we have formed the expression where a is in terms of b.